So good morning, welcome to Sakal Vijay YouTube channel. So now welcome to the Diploma Basic Engineering Mathematics Semester 1 classes. Okay, today we discuss type 4. Type 4. Okay, type 4. Nagesh, welcome. See, if the denominator g of x contains repeated irreducible very good morning. So where are you from, Nagesh? So good morning, Muhammad Salim, Meghana. So I will try, Nana. I will try. Irreducible quadratic factor of the form ax square plus bx plus c all to the power of n. Then there exists partial fractions. Good morning all. Good morning. Partial fractions of the form, see first, a1x plus b1 upon ax square plus bx plus c plus a2x plus b2 upon ax square plus bx plus c whole square. Yes. So plus so on dash dash, you will be getting anx plus bn upon ax square plus bx plus c whole to the power of n. So that means there exist n partial fractions of this form. So where a1, a2, a3 and so on an and b1 comma b2 comma b3 dash dash bn are constants. So they need to be evaluated so as to get the required partial fractions. So this is the type 4. Type 4 is the actually almost the concepts of the partial fractions going to be completed, but moreover the one more special types are there that after completion of this one we will discuss. So let us discuss an example to get more understand about this type. So example. So let us move to example. Example is very important. Please all of you concentrate on the example. Resolve. Question will be given in the examination like this. So good morning, Sridhar. Resolve 2x minus 3 upon x minus 1 times x square plus 1 whole square into partial fractions. So this is the question. Okay, okay, Nagesh. Okay, okay. Very good, very good, very good. Right. Now the solution. So consider 2x minus 3 upon x minus 1 times x square plus 1 whole square. For x minus 1 is actually non-repeated linear factor. So for x minus 1 there exists a partial fraction of the form a upon x minus 1 constant by x minus 1 plus here x square plus 1 is the irreducible quadratic factor, but it is repeated for 2 times. So 2 more partial fractions we shall get it. That will be in the form of bx plus c upon x square plus 1 plus for x square plus 1 whole square also we need to write say dx plus e upon x square plus 1 whole square. Say equation 1 this is. So sir, I hope I recognize it, Sridhar. Actually I will start, I am so busy actually. After this I start Eamcet classes. So this followed by the Eamcet classes. Let me complete first of all chapter. Then after that I will start it. Please wait. So now 2x minus 3 upon x minus 1 times x square plus 1 whole square. Here LCM. What is the LCM? You will be getting x minus 1 times x square plus 1 whole square. X minus 1 gets cancelled. A times x square plus 1 whole square plus x square plus 1 cancel. We have bx plus c into x minus 1 into x square plus 1 plus x square plus 1 whole square, x square plus 1 whole square cancel, x plus e into x minus 1. So comparing on both sides, what happens now? This x minus 1 into x square plus 1 whole square, x minus 1 into x square plus 1 whole square cancel. So that means a times x square plus 1 whole square plus bx plus c times x minus 1 times x square plus 1 plus dx plus e times x minus 1 equals to 2x minus 3. That we need to write it now. So therefore, so we have a times x square plus 1 whole square plus bx plus c of x minus 1 into x square plus 1 plus dx plus e into x minus 1 equals to 2x minus 3. With the help of this, we need to find out a value, b value, c value, d value, e value. So let us find out now. Right, let us move to the next page. Okay, so now here see, first here we have x minus 1 factor and x minus 1 factor. So if you suppress x minus 1, that means x minus 1 is equated to 0. You get x is equal to 1. That means put x is equal to 1. If you put x is equal to 1, what do you get now here? A times, here 1 square is 1, 1 plus 1 whole square plus this is 0, 0 into something 0, 0 equals to 2x minus 3. So that implies a into 1 plus 1 2, 2 square is 4 equals to, Here you will be getting 2 into 1, sorry, 2 into 1 minus 3. That will be 2 minus 3. So 4a equals to minus 1. A value equals to minus 1 upon 4. Swaruparani. Right. A is equal to minus 1 upon 4. Now comparing x square whole square means x to the power of 4. X to the power of 4 coefficients on both sides. Coefficients on both sides. Okay, let me explain. See x square whole square is x to the power of 4 into a. So you will be getting a plus here see bx into x, bx square into x square, bx to the power of 4 plus b you will be getting. Here we don't have any x to the power of 4 coefficient. So in the right hand side we don't have any x to the power of 4 coefficient equated to 0. So that implies b equals to negative a. So that means minus of minus 1 upon 4. 1 upon 4. B equals to 1 upon 4. So B value have been obtained now. So now let us compare comparing x square coefficients. On both sides. X square means here see if you expand this one here you will be getting 2x square x square term 2 into a 2a. So here you see bx into x bx square into 1 bx square plus b you will be getting cx c into minus 1 minus c x square minus c equal to there is no x square coefficient in right hand side so 0. So now we can write c equals to 2a plus b. Substitute a value and substitute b value. 2 times a 2 into minus 1 by 4 minus 1 by 2 plus b 1 upon 4. So now 4 is the LCM. 2 minus 2 plus 1. This will be minus 1 upon 4. So C value equals to minus 1 upon 4. Still we need how many values now? Still we need D value and E value. That we need to find out. So what is the partial fractions applications in real life? So very good question you asked. So wait, definitely I will give the answer to you. Right. So now the x to the power of 4 and x square coefficient. Next, if you want to get x cube coefficient also we can find out. See x cube coefficient. Right. Yes, C value is known, B value is known. Okay, what? Let us find out comparing this time. So now comparing coefficient of x on both sides. X on both sides. So coefficient of x on both sides means actually see here we don't get any coefficient of x square. You check it now. Bx into minus 1 minus bx into 1 minus bx. So that means you will be getting minus b. Next, cx into 1, cx plus c. Here dx into minus 1 minus dx minus d and plus ex. E equal to what? Coefficient of x is 2 here. So now you see the previous values. What are the previous values? A minus 1 by 4, B 1 by 4, C minus 1 by 4. So let us write now. A is equal to minus 1 by 4. B value obtained, C value obtained. Go back. So B value is 1 by 4. C value is minus 1 by 4. This is minus 1 by 4. So substitute here. Substitute. So what do you get now here? Minus 1 upon 4. This will be minus 1 upon 4 minus d plus e equals to 2 we have. So minus 1 by 4 minus 1 by 4 minus 1 by 2 minus d plus e equals to 2. So e minus d equals to 2 plus 1 by 2. This is 5 by 2. Okay. Now comparing constant term. Comparing constant term or constant terms on both sides. Let us see what are the constant terms. Let me explain. See here 1 square is 1, a into 1 a, that is here c into minus 1 minus c into 1 minus c, that will be minus c. Okay, minus c. Now here constant term you are going to get, you see, plus e into minus 1 minus e equal to, here constant term is minus 3. So let us substitute respective values. A is minus 1 by 4, C is minus 1 by 4. So you get like this. That implies A is minus 1 upon 4 minus C plus 1 upon 4. So now minus E equals to minus 3. Minus 1 upon 4 plus 1 upon 4 cancel. Minus E is equal to minus 3. E will be 3. Now we need to find out D value. So from this we'll get D value here. Since E is 3, E minus D is equal to 5 by 2. So that implies we get 3 minus D equals to 5 by 2. So D equals to 3 minus 5 by 2. This is 6 minus 5, 1 upon 2. Now we know all the values. So this also the coefficient of x square. Why don't you take it before step? So you can take anything, Nana, no problem. No problem. So we know all the values. See A value, B value, C value and D value and E value. So we have A value, B value, C value, D value and E value. So let us write it. This is minus 1 by 4 plus 1 by 4. This is minus 1 by 4. Next D and E. D and E. D is 1 by 2, E3. D 1 by 2, E3. So therefore, so now partial fractions we need to write it. Partial fractions. A is minus 1 by 4, B is 1 by 4, okay, C is let us go back. Okay. Let me check here first of all. So first I have forgotten this one, comparing x cube coefficients on both sides. X cube coefficients on both sides. Yes, you are correct, Chinna. Right, coefficient of x cube means here we don't get it now. Bx into x bx square. Otherwise we can write bx into x square. Bx cube b, you will be getting cx into x square, cx cube plus c. Here b plus c. Okay. See bx into x, bx into x, bx square, right? Bx square into plus 1, right? Mm, bx into x, bx square, bx cube plus b. Next cx into x square, cx cube plus c equals to 0. Now c equals to minus b. That will be minus 1 upon 4. C equals to minus 1 upon 4. Right, C value obtained. Right. So now comparing coefficient of x square on both sides. That is, here 2x square, 2a, you will be getting bx into x, bx square, bx square into b plus b. Now c into minus 1 minus c cx square minus c plus dx into x dx square plus d. Here coefficient of x square is 0. So that implies we have d equals to c minus 2a minus b. Let us go back. So what is the a value? Minus 1 by 4. Okay, b, c, we know. Since a equals to minus 1 by 4, b equals to 1 upon 4, c equals to minus 1 upon 4. Substitute now. So this equals to minus 1 upon 4, minus 1 upon 2, plus 1 upon 2, minus b, minus 1 upon 4. So d value will be yes, something I did wrong. This is minus b. Okay, plus b plus 1 by 4. C is plus 1 by 4. Yes. C is plus 1 by 4. Yes, plus 1 by 4. 1 by 4 minus 1 by 4 cancel. D is 1 by 2. So D value is 1 by 2. Now we need just E value. A, B, C, D known. Okay. Right. So next now comparing constant term on both sides. Comparing constant term means here 1 square 1 into a, that is here actually c into minus 1 minus c into 1 minus c. Now e into minus 1 minus e. Okay. Minus e equal to constant term is minus c. So we get e equals to a minus c plus 3. So a value is negative 1 by 4. C is 1 by 4. Negative 1 by 4 plus 3. Here 4 is the LCM. Minus 1 plus 12. This is actually you have 10 by 4. 10 by 4. 10 by 4 means 2 5 ja 2 2 ja. So 5 upon 2. So E value is known, that is 5 upon 2. Now we know A value, B value, C value, D value and E value. Just substitute and find the partial fractions. Right? Now we get A equals to minus of 1 by 4. This is D value and E value changes. What is the D value? D is 1 upon 2. This is 5 by 2. See 1 upon 2. 1 upon 2. 5 by 2. So therefore partial fractions 2x minus 3 upon. Yes. 2x minus 3 upon x minus 1 into x square plus 1 whole square. See a upon x minus 1 plus bx plus c upon x square plus 1 plus dx plus e upon x square plus 1 whole square. So let us substitute. Minus 1 by 4 upon x minus 1. B is 1 by 4. 1 by 4 times x plus 1 by 4 upon x square plus 1. D 1 by 2 plus 1 by 2x E plus 5 by 2 upon x square plus 1 whole square. Further you can simplify this one. This is minus 1 by 4 times x minus 1. 4 LCM. You get x plus 1 upon 4 times x square plus 1 plus 2 LCM x plus 5 upon 2 times x square plus 1 whole square. This will be very lengthy, type 4. Please remember, try to solve carefully. Now special type. Special type. See, special type means if f of x by g of x is an improper fraction. Improper fraction. So then first divide f of x by g of x, then express it as f of x by g of x equals to q of x plus h of x by g of x, so that h of x by g of x is a proper fraction. Then find partial fractions of h of x by g of x as we discussed earlier. So this is the process we need to find out. Special type. Whenever f of x by g of x is an improper fraction, directly we cannot find out the partial fractions. First we need to make it proper fraction, then we need to find out the partial fractions of proper fraction itself only. So Laddu Chinna, I will explain that question once again. Whenever the same type of problem we will solve later. First one example let us discuss now. Now example. Resolve x cube by x minus 1 into x minus 2 into partial fractions. Generally one must be tempted to write directly a upon x minus 1 and b upon x minus 2, then you will find out the partial fractions. Now here you just check x cube, degree is 3, x minus 1 into x minus 2 means x square. Degree of numerator is greater than degree of the denominator, so it is an improper fraction. Improper fraction means first we need to divide x cube by x minus 1 into x minus 2, then so we need to write as like this form. See, quotient plus this is a remainder by the divisor. This obviously this becomes the proper fraction. Now the proper fraction, then partial fractions of this one we need to find out, plus quotient you will get the answer. So let us see this question now. How to solve? Solution. First consider x cube upon x minus 1 into x minus 2. So now x minus 1 into x minus 2 product let us find out. X into x, x square, x into minus 2, minus 2x, and this will be minus x, minus 1 into minus 2 plus 2. So this equals to x square minus 3x plus 2. So now divide x cube by x square minus 3x plus 2. We need to divide. How to divide? Take x cube, simple division, x square minus 3x plus 2. See, now this x cube is divided by x square. If you divide by x square, you get x. You write down x. X into x square x cube, x into minus 3x square, x into plus 2 plus 2x. Now change the sign. This is minus, this becomes plus, this becomes minus. This gets cancelled. Note down, this is 3x square minus 2x. So now again actually check the degree. This degree is Same. So again we need to divide 3x square by x square. See, 3x square by x square, you get 3. That means still in the quotient you get the constant, you need to continue the division. Here plus 3 write down. 3 into x square, 3x square. 3 into minus 9x, minus 3x. 3 into 3, 9, minus 9x. 3 into plus 2, plus 6. Change the sign. Minus, plus, minus. So 3x square cancel. 9x minus 2x is 7x. This will be minus 6. Now this can be written as using division algorithm. That's called division algorithm. So we have x cube upon x minus 1 into x minus 2 equals to, we can write like this, x plus 3 plus remainder. What is the remainder? Remainder is 7x minus 6. 7x minus 6 upon x square minus 3x plus 2. See equation 1. Now the partial fractions of this proper fraction we need to find out. So now here consider 7x minus 6 upon this x square minus 3x plus 2 factors are this x minus 1 into x minus 2 only. This comes under type 1. We need to recall. This is very, very important. Here it is in the form of f of x by g of x. G of x contains non-repeated linear factors. So there exist two partial fractions, a upon x minus 1 plus b upon x minus 2. So now this 7x minus 6 upon x minus 1 into x minus 2 equals to, here LCM is x minus 1 into x minus 2. X minus 1 cancel, a times x minus 2 plus x minus 2 cancel, b times x minus 1. See, this x minus 1 into x minus 2, x minus 1 into x minus 2 cancel. We have a times x minus 2 plus b times x minus 1 equals to 7x minus 6. Okay. So once again the type 1 process will be here revised. Suppress x minus 1. Suppress x minus 1 means x minus 1 is equated to 0, x is equal to 1. Put x is equal to 1. That implies a times 1 minus 2 plus b times 0 equal to 7 into 1 minus 6. So a into minus 1 plus 0 equal to 7 minus 6. So we get like this. Minus a equals to 1. So a equals to negative 1. A value obtained, have been obtained. Okay, next now suppress x minus 2. Here put x is equal to 2. So that implies a times 0 plus b times 2 minus 1 equal to 7 into 2 minus 6. This will be b into 1 b, 14 minus 6. That will be 8. So b value is 8. So we know a value and b value. The partial fractions of the part of the problem has been completed now. Thank you. Now minus 1 and 8. So therefore now since 7x minus 6 by x minus 1 into x minus 2 is equal to a upon x minus 1 plus b upon x minus 2. So what is the a value? A value is minus 1, b value is 8. A value is minus 1, b value is 8. So this equals to minus 1 upon x minus 1 plus 8 upon x minus 2. But we need partial fractions of the given problem. So from equation 1, so we have therefore x cube by x minus 1 into x minus 2 partial fractions equals to, go back to equation 1. Here x plus 3 is there, plus partial fractions of this one we need to write it. So we get x plus 3 and partial fractions of this one, plus of, we have minus 1 upon x minus 1 plus 8 upon x minus 2. So this equals to x plus 3 plus into minus 1 upon x minus 1 plus into plus 8 upon x minus 2. So these are the partial fractions of required one. So in this way we can find out partial fractions of a here improper fraction. So improper fraction. Shall I proceed for next problem? Okay, one more question I will discuss now. Second example. This is the first example. Say first example. Okay, second example. Resolve x square upon x square minus 3x plus 2. X square minus 3x plus 2. Right. Into partial fractions. Into partial fractions. See, first you check this question, x square. Degree of the numerator is 2, degree of the denominator is 2. Then f of x by g of x is called actually improper fraction. So first we need to divide this one. You will get 1 because x square means x square coefficient 1, x square coefficient 1. 1 plus something partial fractions we need to write. Solution. So consider this x square upon x square minus 3x plus 2 equals to, since whenever equal directly we can write coefficient of x square is 1, coefficient of x square is 1, 1 plus you will be getting something we do not know. What do you get it now here? So that we need to find out. By division we need to find out now here. Otherwise directly we can write the partial fractions like this. See, this x square minus 3x plus 2 factors are x minus 1 into x minus 2. This is a previous problem only model. This we can write a upon x minus 1 plus b upon x minus 2. Say equation 1. This directly we can proceed this problem. So this can be rewritten x square upon x minus 1 into x minus 2, because instead of x square minus 3x plus 2 we can write x minus 1 into x minus 2. Okay, thank you Muhammad. This equals to x minus 1 into x minus 2, x minus 1 into x minus 2. Now x minus 1 cancel, a times x minus 2, x minus 2 cancel, b into x minus 1. Okay, So now x minus 1 into x minus 2, x minus 1 into x minus 2 cancel. So now we have x minus 1 into x minus 2 plus a times x minus 2 plus b times x minus 1 equals to x square. So now let us use the suppressing. Here put x is equal to 1. So if you put x is equal to 1, the x minus 1 becomes 0. This also becomes 0. 0 plus a times 1 minus 2 plus b times 0 equal to 1 square. So this is minus a equals to 1. That implies a equals to negative 1. This is the a value. This is the a value. Right. So let us move to next one now. You know the a value now. Again take this expression. Right. So now this time suppress x minus 2 factor. That means put x is equal to 2. So moreover, the x minus 1 into x minus 2 becomes 0. 0 into something 0 plus a into 0 0 plus b times 2 minus 1 equal to 2 square. So now what do we get? This is b equals to 4. So now therefore x cube upon x square minus 3x plus 2 equals to we have 1 plus a upon x minus 1 plus b upon x minus 2. Let us substitute the values. What is the a value? A value is equal to minus 1. So we get like this. 1 plus of minus 1 upon x minus 1 plus b equals to 4. 4 upon x minus 2. Therefore partial fractions 1 minus 1 upon x minus 1 plus 4 upon x minus 2. So this is the answer. Yes, Tarun Teja, absolutely correct. Okay, now let us move to the third problem. Third, resolve x cube upon x minus 1 into x plus 2 into partial fractions. Can you do this problem now? Can you do it? Are you able to solve this problem? Just you think up what are the partial fractions, what is the procedure need to be followed? Okay, first find x minus 1 into x plus 2. So let us multiply. See, x into x, x square, x into plus 2x, minus 1 into x, minus 1 into plus 2, minus 2. So we have x square plus x minus 2. Here degree is 3, this degree is 2. Degree of numerator is greater than degree of the denominator. So it is a improper fraction. That means x cube should be divided by x square plus x minus 2. After that, we need to find out the partial fractions. Okay, now the solution. So now consider x cube upon x minus 1 into x plus 2. So this equals to x cube upon x square plus x minus 2. First we need to divide x cube. X square plus x minus 2. So all of you carefully observe how to divide. First x cube divided by x square. X cube divided by x square, you get x. Because x square into x is x cube. X write down. X into x square x cube. X into plus x square. X into minus 2 minus 2x. Then subtract. You need to change the signs. Minus, plus changes to minus, minus changes to plus. X cube gets cancelled. We have negative x square and plus 2x. So now this negative x square divided by x square. Negative x square divided by x square, you get negative 1. So you got negative 1 is a constant. Stop now. Minus 1 into x square minus x square. Minus 1 into plus x minus x. Minus 1 into minus 2 plus 2. So that means change the signs. This changes to plus, this changes to plus, this changes to minus. X square cancel. This is 3x, 2x plus x minus 2. So therefore, this x cube by x minus 1 into x plus 2 is written as x minus 1 plus 3x minus 2 by x square plus x minus 2, or x minus 1 into x plus 2, we can write it. So that means actually we are going to write like this. So now x cube by x minus 1 into x plus 2 equals to x minus 1 plus 3x minus 2 by x square plus x minus 2. So this also can be written x minus 1 plus 3x minus 2 upon the factors of x square plus x minus 2 is nothing but x minus 1 into x plus 2. Say equation 1. So now the partial fractions of this part only we need to find out. So consider proper fraction. What is the proper fraction? 3x minus 2 upon x minus 2 into x plus 2 equals to a upon x minus 1 plus b upon x plus 2. So let us find out the partial fraction. This comes under type 1. So now what shall we do now? Yes, 3x minus 2 upon x minus 1 into x plus 2. Here LCM is x minus 1 times x plus 2. So a times x plus 2 plus x plus 2 cancel, b times x minus 1. So now x minus 1 into x plus 2, x minus 1 into x plus 2 gets cancelled. Here we have a times x plus 2 plus b times x minus 1 equal to 3x minus 2. So let us follow the suppressing method. Here x minus 1 is being suppressed, that means put x is equal to 1. That implies a times 1 plus 2 plus b into 0 equal to 3 minus 2. This is 3a equal to 1. A value is 1 upon 3. A value is 1 upon 3. You check Nana once again. You check once again. Tarun Teja, once again check it. Put x is equal to minus 2. So that implies what you get now here? Yes, a into 0, 0, a into 0 plus b into minus 2 minus 1 equal to minus 6 minus 2. So this will be minus 3b equals to minus 8. B value will be 8 by 3. Minus minus gets cancelled. This is the B value. Now we know A value and B value. So we have three x minus 2 by x minus 1 into x plus 2 equals to a upon x minus 1 plus b upon x plus 2. Here what are the values of A? A is 1 by 3. B is 8 by 3. Substituting 1 by 3 upon x minus 1 plus 8 by 3 upon x plus 2. So this can be written as 1 upon 3 times x minus 1 plus 8 upon 3 times x plus 2. But these are not partial fractions. We need to go back to the equation 1. What is the equation 1? This is the question. So x cube by x minus 1 into x plus 2 is equal to x minus 1 plus partial fractions of this one we need to write. So therefore, from equation 1, therefore x cube by x minus 1 into x plus 2 equals to x minus 1 plus partial fractions of this one. So these two partial fractions need to be added. So 1 upon 3 times x minus 1 plus 8 upon 3 times x plus 2. So these are the partial fractions. So thank you. We shall continue. Deepak Yadav, thank you. Thank you. We shall continue in the next session. Thank you. Bye bye.